Next one, determine whether it's even, odd, or neither. So I did talk about before, and I'll say it again, the algebraic definition is that when you substitute negative x in the function, the negative quote unquote disappears. That's what I like to tell people. In other words, you get back the original function. And that graphically means that it has symmetry over the y-axis. An odd function, to figure if it's odd, it's the same step. You still substitute negative x into the function. But I like to tell people, easy way to remember it, if the negative quote unquote comes out, then it's going to be an odd function. So in other words, there's that imaginary -1 times there, right? So I'll talk about that later, because a lot of people get confused as to how to do the odd. So you practically just pull out a -1, and then, do the distributive property. But again, if you have no idea what I just said, we can definitely do that later. All right. And then graphically odd would mean that it has symmetry over the origin. So as I said, very first step is going to be anyway to substitute negative x into the function. So again, I always tell people when you make a substitution, you always hug the x with the parentheses, okay? Super important that people get confused because there should be a negative outside of the parentheses as well as inside of the parentheses, right? We're making the substitution in the parentheses, as you can see. So plus 3, again, parentheses, negative x to the third power. And then super careful, right? We're substituting negative x, notice inside the parentheses, so we should have a minus parentheses negative x, right? That's going to end up turning into positive x, right? Okay, so now we're going to follow PEMDAS. So PEMDAS says we're going to do the exponents first. So we're focusing on this, right? Negative x is the base of the exponent 5. So what's negative x times negative x, right? Times itself 5 times. It's going to be negative x to the 5th, right? So you're going to see that that sign stays negative. Or as I said earlier, the shortcut is going to be anything raised to the odd power is always going to be negative, right? So that simplifies to negative x to the 5th. And then drop down this negative, right? So notice what's the difference in what was written before and what's afterwards is notice now the 5 is inside the parentheses as opposed to outside the parentheses, right? So that's the difference. But I left the parentheses here. Technically speaking, if that confuses you, you could technically write this negative right here is an imaginary -1 times, right? So again, if that makes you feel better, you can certainly write that down. Anyway, okay, so then we're doing the other exponent. So I'm dropping down the plus 3 times. Again, anything raised to the odd power is going to be an odd sign. And then, right, so this is technically saying here, -1, let's see, I guess I'll keep it in red. This is like saying -1 times negative x, right? So, which is going to end up being a positive, right? Or two minuses next to each other, it's going to make it a positive. So, I guess we can just write plus x here since we know what that would be, right? Now we're doing the multiplications. So a negative times a negative, so this would turn into a positive times a negative, so that's going to be -3x to the third, and then drop down this plus x. There are no more like terms because all the exponents are different. So now it's time we're going to ask ourselves, okay, so is it even? If it's even, it would have to be equal to the original function. Okay, this is the original function. That's negative x to the 5th. Oh, stop. This is positive x to the 5th. Already, it's not even, right? They have to be 100% the same. So it's not even. Now, to figure out if it's odd, reminder, this right here, there's an imaginary -1 times f of x, right? So you're always going to pull out a -1. Technically, you could just write negative, but so you're going to that's essentially you're taking out a common factor, right? So we're going to do the reverse distributive property. So -1 times what would have to give me a positive x to the 5th? We need a negative, right? And then a -1 times what gives me a minus 3x to the third. So if you see a pattern, when you pull out a -1, just all the signs are going to be different, okay? So now the question is, right? So again, I do not need this -1 here, so I'm just going to write, right? So the question is this equal to f of x, right? Because remember this negative, right? So for it to be odd, it would have to be equal to negative f of x. So you're going to look in here and you're going to compare. Is that the same thing as the f function? Well, that says -x to the fifth, right? Okay, -x to the fifth, plus 3x to the third, yep. And then minus x, yep. So that is equal to f of x. So again, what have we just done? We have substituted -x into the function. We then simplified it, pulled out a -1, and we have just proved that it's equal to negative f of x. Therefore, it is odd. Okay, so if that was not equal to f of x, then the answer would be neither, right? I hope you found this video really helpful, and I want you to make sure that you check the description. I left links to also my online course if you're interested. I have chapter modules and quizzes and homeworks and step-by-step answer keys, and I have video lessons of those. So again, I left that link in the description. Make sure to like and subscribe, and make sure that you also leave a comment so that if you want to also request any future videos, I'd be more than happy to make those. So I hope to see you soon.